In this figure, you can see the general scenario. The goal is to show how a close control loop including the NWDAF and OAM can dynamically allocate bandwidth to priority users by surgically limiting others. This cannot be achieved statically, with mere differentiation by user profile on the network. In this figure we show the overall demo scenario. At start, a normal, non-gold, vehicle, UE1, connects to the GNB1, and data traffic is exchanged with the IPERF server on the private network, via UPF1. The UPF generates IPFIX records for all the active data flows on the UPF and streams them to the OAM platform where a complete data processing framework is running, the TIC stack. TIC stack, Telegraph, InfluxDB, Capacitor, and Grafana, instead of chronograph. The computation of the bandwidth is performed in real time and displayed on the Grafana dashboard for all UEs, IMSIs, using the UPF at a given moment in time. If more vehicles arrive, when they reach the bandwidth limit, some of them will have their bandwidth limited. First, we start the GNB1 and the UE1, non-gold, regular, user. We need to add a route in the UE to make this traffic go to the correct interface. Now, we can start an IPERF session with 400 megabits per second. In the OAM, we can show that we are receiving the IPFIX messages. If we go to the container OAM capacitor, we can see a running active task. That task is calculating the bandwidth based on the received IPFIX records for all UEs in real time. In Grafana, we can show that the bandwidth is around 400 megabits per second. Now, we start the UE2, gold, and start a simple ping from the correct interface. In Grafana, we can see that the bandwidth calculation is very accurate, since all traffic modifications become evident. This is possible because we are sending IPFIX records for each flow that crosses the UPF1 in both directions. The relative lag of data appearing in Grafana graphs is due to the IPFIX record collection window, plus an aggregation time of 3 seconds in InfluxDB. For UE1, the bandwidth is around 400 megabits per second. Going back to the UE1, we can change the IPERF session bandwidth to 300 megabits per second and see the result in Grafana. UE1 currently does not face any limitations on its bandwidth usage and, as such, is able to freely utilize all the bandwidth it can handle. Going back to the UE1, we can change the IPERF session to 100 megabits per second and see it in Grafana. And then back to 300 megabits per second. We can change the graph timescale to see the last minutes for UE1 and see the changes from 400 megabits per second to 300 megabits per second, then 100 Mbps and 300 megabits per second. The UE2 continues generating, receiving its traffic freely. In this figure you can see the scenario. At start, the vehicle, UE1 non-gold, connects to GNB1, and the data traffic is exchanged with the IPERF server on the private network, via UPF1. The OAM receives the IPFIX records from the UPF1, aggregates the data, and delivers these metrics to NWDAF. When a gold user traffic is detected, the NWDAF will generate a notification to the PCF, which will apply a specific throttling rule to active, non-gold sessions over the SMF. First, we start GNB1 and UE1, non-gold. We need to add a route in the UE to make this traffic go to the correct interface. Now, we can start an IPERF session with 400 megabits per second. Next, we start the NWDAF, and we can see the metrics in real time. These are the same metrics shown in Grafana. Now, we start the UE2, gold, and start a simple ping from the 5G data interface. At this moment, the NWDAF starts receiving metrics for this new UE. When this occurs, the NWDAF notifies the PCF. The PCF interacts with SMF to apply a rule to UE1, non-gold, session that limits its bandwidth to 100 megabits per second. We can confirm this limit in the NWDAF metrics and also in Grafana. If we stop the UE2, gold, traffic, the NWDAF detects it and acts to remove the rule that was applied to UE1 via SMF. We can confirm that UE1 can now attain 400 megabits per second in the NWDAF metrics and check also in Grafana. We are back to the initial situation.